Kling, who will be our presenter today. Cathy Kling is the Tisch University Professor at Cornell and the Faculty Director of the Atkinson Center for a Sustainable Future. So she was previously the Charles Curtis Distinguished Professor at Iowa State, where she also held the President's Chair in Environmental Economics. So Cathy is a member of the National Academy of Science and has had a prolific career, I would say, with nearly 100 refereed journal articles or book chapters. And I just looked this up yesterday, over 11,000 citations in Google Scholar. It's kind of a lot. She's currently the editor at the Review of Environmental Economics and Policy and Proceedings of the National Academy of Sciences. Has been in the editorial board of other journals. And I'm not sure where she finds the time, but she's also been very involved at the interface of science and policy. She's served on many National Academies panels. She's been also on the EPA Science Advisory Board for about 10 years. And I should throw in that somewhere she found time to also be the president of the Association of Environmental and Resource Economists. Her research focuses on the economic valuation of ecosystem services and integrated assessment modeling for water quality modeling. So it's no surprise that policymakers are interested in what she has to say. And indeed, I think I can speak for us to saying that all of us at Yale FES are also excited to hear what she has to say. So with that, Cathy.
Awesome. That's a nice introduction. Well, it's so much fun to be here. Like FES, Yale, this is the environmental economics place. Like for my entire career, this is a place that really takes interdisciplinary work seriously, sits ecologists, economists together in the same place, working together. So this is really a bit of a pilgrimage. I've got sort of a high-level talk, lots of bits and pieces about water quality, some related to work I'm doing, a little bit related to work that Dave Kaiser and Joe Shapiro did, who many of you will know well, as well as I'm going to end with a series of slides on current work that I'm doing with EPA that's very much, we just put these slides together last week looking at non-market valuation for water quality, and I figured I got a captive audience. I'm going to throw some of these in front of you. We're very much in the process of developing this, so I'm going to get lots of good feedback, and hopefully we'll have some good conversations with students and anybody who wants this afternoon. But I have to tell you the real reason I came and was excited to come to Yale. That woman is Louise Triplett. My middle name is Louise. That is my great aunt who died in 1980 something or another. She was a much beloved aunt in my family. This is a Yale degree. Some of you students who don't have one of these yet will. My aunt earned this degree in, where's the dang, here. You got to be able to read. Back in those days, they didn't use regular numbers. That says 1928. My aunt earned a master's degree, not just an undergrad, a master's degree in 1928. She earned it from the School of Education. However, she should have earned it from the Divinity School, because she came and on a fellowship and studied at the Divinity School, but at that time, they did not give degrees to women. It wasn't until 1934 or something I learned yesterday when I was over in the archives way back in the dark little room, and I found these people who were so excited about my aunt. It was so great. It's like, this is really where scholarship happens. Anyway, this is her actual diploma. The story in our family, and we have a little bit of records, is that she actually took all the same courses, but got a master's degree in education. And when I told them that story yesterday, they were like all excited, because apparently they're coming to a 100th anniversary of something, and they're doing a bunch of work on women early in Yale's graduate education and so on. And so they were cool to see some of this documentation. And so I had a really great fun time over there yesterday. In addition, I came across this beautiful thing, which I instantly decided I had to put up for you. This is from the 1927 Yale Graduate College list of degrees. And it happily tells you all the different degrees. And then right down there, I noticed that at that time, you could get degrees from many graduate places, not Divinity and not the School of Forestry. So, women in this room, We were not allowed. I don't know if we were allowed to come to seminars or not at that time, but no degrees to School of Forestry, up there with the divine. Okay, I had to get that in. All right, now to my actual talk. I have been doing lots of work in water quality and for many years, and that's kind of what I want to do and continue to work on. So I'm going to tell you a little bit about what we know about national trends in water quality across the U.S. I'm going to talk a little bit about economic analysis and its role in policy and decision making as required by various presidents, including the current one. I'm going to talk a little bit about what we know about benefit cost analyses of various water quality regulations. And then I'm going to share with you some slides of development work we're doing in a new stated preference study that I'm going to get free input from all these brilliant minds. So let's start with, what do we actually know about water quality across the United States over large periods of time? Amazingly, this has not been well documented. So the Clean Water Act was passed in 1972. And it had goals of things like completely eliminating all water pollution and all emissions into waterways by 1980, which didn't happen. But they didn't really think to start tracking on a national basis what was happening to water quality despite this Clean Water Act and its various goals. EPA, in the last 15 years or so, realized that they actually don't have a good way of tracking uniformly across time, and so they started these national aquatic resource surveys. These are now done about every 5 years. There's only been a few of them done. They're constantly running into funding problems, but they have 4 different ones: rivers and streams, one that focuses on lakes, one that focuses on wetlands, and one on coastal estuaries. What they did is they took the United States, they divided it up by regions, ecological regions, and for each region, I randomly sampled a set of lakes or rivers and streams from which to do sampling that they can then infer to the entire region. So it's a statistically based, sensible sort of thing. However, it's still very young. And in many cases, and they're only doing them every 5 years, so basically it's a snapshot every 5 years. So after a while, we will indeed have some useful national scale data from this. In the meantime, we can happily rely on Yale School of Forestry and affiliates, like some of them econ people, to come up with some really good data for us where we didn't have it before. So for those of you who don't know Dave Kaiser, he is a graduate of this department 4 years ago, 5 years, something like that. We hired him at Iowa State. So I was happy to be his colleague for a number of years, and during that time he worked with Joe Shapiro, who was at Yale at the time and now at Berkeley, amassing this really incredible data set and doing this really, really great paper. So if you're interested in environmental economics, this is an awesome paper. I'm just going to use it to snapshot and summarize trends in the water quality that we do know about. They had collected about 50 million water pollution readings from a whole bunch of different places. They put it all together, different monitoring sites, put it all together so that for the first time we had a national assessment both across space and a long period of time to get a sense of what's happening to water quality in this country. So I'm using this not to talk about any of the cool economics work they did, but just as a way to give you insight into what we actually know about water quality and what successes and lack of we've had. So this is a nice picture directly from their paper where they are monitoring from 1962 to 2001, where they are reporting all of these different monitors on saturated deficit. This is dissolved oxygen, which is commonly put on its head. The point being that a decline here is good. Okay, so often you see this plotted as DO where it would be the other direction, but a decline here is good. So averaged over all of these over this long period of time, this doesn't say anything about regional differences, it doesn't say anything except just what's going on across the long period, things are definitely getting better. Clean Water Act was the focus of their paper, and so that's what that red line is there, and it was too hard for me to Photoshop it out, so it's still in there, but all I want you to do as a takeaway is that on that metric, which they were able to put together a really large data set over a large space, clearly doing better. Same is true for a equivalent metric, which is fishable. Okay, and in this case, it's the share not fishable, again, done so that a decline is an improvement. Very clear, things are getting better. It doesn't say anything about whether it's good enough or not good or too good or anything. We're just, boom, it's getting better. Okay, and we have spent lots of money. I'm going to tell you a little bit about some of the money we've spent that hopefully is due, that there's a reason that some of that hopefully is due to the actual decisions we've made. But they also looked at some other metrics. Variety of things that get used to measure water quality. Negative significant numbers mean it's improving. There are two noticeable types of pollutants that we care about that are not polluting, and indeed one of them is significantly positive over this period of time. A conjecture that I don't think is too far out there is that this is because we have not addressed water pollution from agriculture in anywhere near the way in which we have tackled point sources and to some extent non-point sources in other industries and in other areas. Okay, so that's kind of the take-home for purposes of my talk, is that while we have made clear improvements, for whatever reasons, in lots of metrics we care about, there are some important ones, notably related to N, nitrates, nitrogen, that we have not. Another indicator of that assertion that this is that agriculture is a big problem is what I think we can think of as a canary in the mine sort of notion, hypoxia in the Gulf of Mexico, the so-called dead zone. Just a quick show of hands, is this something people have heard is on your radar? Everybody knows what the dead zone, yeah, okay. So this is a map of the US, obviously. This is the size of the hypoxic zone in the range at which that it gets measured. This is the watershed that contributes to that size. About 2/3 of the continental US dumps into, so it's not surprising that you're concentrating an awful lot of nutrients. And I overlaid a map here with where we grow corn and beans, which is where most of the N is probably, well, is definitely coming from. I don't need happily to explain to this group what this is. You bring all these nutrients down into the Gulf. It sits there and does what nutrients do. It grows stuff, phytoplankton, bacteria, and other things. And when it decomposes, it uses up oxygen in the water. So that's the cause of the hypoxic zone. This is the 1-year time series measure that Nancy Rabelais does each year. She takes her boat, the Pelican, out and measures the aerial size of the dead zone. And you can see it's all over the place. Huge weather variability is what really contributes a lot, as well as droughts are good because it doesn't flush nutrients down. So drought is really good for the dead zone, not so good for people in corn upstream, but good for the dead zone. Takeaway from this, things are not getting better, probably worse. Yet again, another indicator that nitrogen, nutrients in pollution are a problem. Okay. What I really want to then move to is the role of economics in assessing and thinking about these issues and problems. People that study environmental economics know a lot of this, but others probably don't. And that is that there has been a very important role in our federal government for the role of benefit cost analysis that has been promulgated by every president since Ronald Reagan. In 1981, Reagan issued Executive Order 12291, which was a requirement that all major regulations in the United States, major meaning more than $100 million worth of activity, of economic activity, should have a benefit cost analysis undertaken to determine whether the benefits exceed the costs. So all these regulations now go through the Office of Management and Budget. OMB has a huge role in all of this. And this is a requirement that every president since Reagan has reaffirmed and made their own variations on. So in 1993, Clinton issued 12866, and under the Clinton administration, it explicitly said, what I've written down here is what I've indicated is the decision rule that they write in the actual legislation. So you can go to the Federal Register and see these words or something very close to them. What Clinton did is said not just that you should choose to maximize net social benefits, but you should maximize net benefits and also think about other stuff, okay? And so cost-benefit analyses after that time started to add distributional consequences, which is important and valuable. In 2011, Obama issued an executive order, there's the number, that added some of this language, that we ought to choose, the decision rule is we should be proposing or adopting regulation which, upon a reasoned determination, its benefits justify costs, acknowledging that some are difficult to quantify, which when you're talking about environmental issues is really important. We ought to select those that maximize net benefits, and we ought to have lots of public participation. Okay. Trump administration comes in, and they issue Executive Order 13771, and there's some people in this room who've done some important, valuable work and published some really good things related to this. Kudos to that. This was added. For every one new regulation, at least two prior must be identified for elimination, and the total incremental costs of all new regulations should be no greater than zero. So let me just say, as an economist and as a practitioner of benefit cost analysis, there's no basis in any economic logic for this. Just be very clear about that, and if anybody wants to debate it, we can discuss that later. But there's just nothing that from any textbook, anything about economic efficiency, which is the entire basis for doing benefit cost analysis, that would justify something like that. But anyway, that's what it says. Well, then agencies have to actually figure out how to do these things. And OMB, Office of Management and Budget, often issues guidance. So this is the guidance that came out. Because notice that this says focus only on the cost part of the ledger. Well, when you do benefit cost analysis, when you think like an economist, benefits are negative costs. And costs are negative benefits. They often aren't obvious which side they go in. There's an arbitrariness to it, and we're perfectly comfortable with that because it doesn't matter. Because you're going to add up all the pluses, you're going to add up all the minuses, you're going to figure out where the pluses and minuses hit different distributional things, you're going to, right? I mean, but it's not a problem conceptually if you're thinking about efficiency in economics. But if you're going to make a firm decision rule that says, we got to be sure all the costs. Well, suddenly you got to figure out what bucket to put things in, and it's going to matter. Okay, so you can read this, and I won't take more time. But they actually give examples of when you're deregulating, medical costs that might have been counted as benefits should now be counted as negative cost savings. Well, here's what that means. If we deregulate something under this rule, and the costs of medical care increase because of it, because we deregulate, it's not going to count as a cost. Exactly. I'll leave you with that. Okay, what do economists actually say about this? Well, economists had a lot to say about this over many years, and my favorite, the one I use all the time, is a paper that Ken Arrow, kind of famous dude, and a bunch of other pretty famous, smart people wrote. One short piece in Science. If you don't have this as something you cite all the time, get it. What do they say? Well, they say, benefit cost analysis is really important. It really helps us think things through. But we can't quantify everything. We know that. And you shouldn't discount things that you can't quantify. And let's be clear here. It's an efficiency thing only. That's all it does. That decision rule can't do other things. So I think that this is, I certainly support this kind of notion. Recognize that it's really valuable, but take its limitations. And if you're not going to follow a strict benefit cost rule in a policy decision or something, be able to explain why and defend it in a sensible way. Okay, so that's what I think is probably the best. Okay, so that's kind of the story of where I want of what the regulations require, what economists and so on think. Now, the next thing I want to talk about is we've had water quality improvements in some places, not in others. We have these requirements that we do benefit cost analysis. What do the benefit cost analyses that we've done of regulations on national clean water or regional clean water standards tell us about the benefits versus the costs? Well, Dave Kaiser, Joe Shapiro, and I wrote a real simple piece that was just been published in the Proceedings of the National Academy of Sciences as part of a symposium last year, where I put together a very simple table to start with. How much have we spent? What have the costs been for regulations and activities that we've done in the last, since 1960? Have we spent a lot of money? Have we put a lot of expenditures into this? Not benefit side yet, just cost side. Well, this is just data you can easily get from various government sources. And it's three types of spending on water pollution control efforts. Non-point source, industrial, and municipal. The bottom one is non-point source. That is largely the Conservation Reserve Program, which sets land aside as part of the Farm Bill. It's a giant program. It's one of the largest conservation programs in the United States. It might be the largest in terms of expenditures. Has a huge impact on all kinds of environmental stuff, including water quality. So that's basically the Conservation Reserve Program and other such programs. This industrial is from the PACE survey, the Pollution something Expenditures survey. I'm looking at the Economist. Pollution Abatement Control Expenditures survey. That is a survey of industry firms asking them to detail what they have spent on a variety of things. So that's basically private sector funding, and much of that is to address regulations. This is all the money in municipal. That's to improve wastewater treatment systems all across the U.S. And that was really the focus of the work that Kaiser and Shapiro did, looking at the effect of that. Okay, so that's a lot of money. It's also plotted in terms of percent of GDP, so anywhere from 0 to almost 0.5%. That's been declining in the last several decades. Big upsurge right after the Clean Water Act was passed. Okay, we spent a lot of money. What have the benefits of that spending been? Well, here is a list, and you don't have to go through it. I'm not going to torture you to look at it. This is a list of a bunch of regulations, a bunch of benefit cost analyses that have been done, some as required by agencies, others by academics, ex post or ex ante for various regulations. They've been done in very early years. These are standard academic environmental economist types. Leroy Hansen, a lot of these have been done for specific programs. Some of these are specific rules and a little bit more recent. Here is the simple benefit to cost ratio. You will notice that almost all of them are less than 1. That means the benefits are less than the costs in the study for that thing, whatever it was that they're studying that they did. Okay? Dang. As an environmental economist, I kind of hate to see that. So we see this and we're like, well, you know, that's what they are. What's going on here? Well, one very logical answer is the costs exceed the benefits, and that's just the way it is. And we have either not implemented programs very efficiently, or we have over-regulated, or any of the other things that could literally achieve that. Being nerdy academics and a little bit of an enviro under my hood, I'm like, is that really, do I really believe that? I don't think we know the answer. So I know we don't know the answer. One answer is the one I just gave, that it really just is just true, and that could just absolutely be correct. Another possible answer, though, is that we have not been assessing benefits and or costs accurately, and I think that we have a lot more work to do on the benefit side. It's probably work to do on the cost side too, but I think we are particularly limited on the benefits side. And we talk about this in the paper and basically make sort of a call to arms that we need to do a lot better in thinking about what all the benefits are of water quality improvements and whether we are really accurately capturing them. Again, it could be the case that the benefits don't exceed the costs. I am not in any way saying, you know, this is wrong and we have to get the right answer out of this. No. But if it's not complete, then we ought to do a better job of trying to figure out whether it's complete or not. And I really think that we have a lot more work to do on missing measures of ecosystem services and valuation of those endpoints. To give you a flavor for the argument that I'm proposing here, I want to just run through a whole list of the types of benefits that could be affiliated with water quality improvements. Health. So drinking water benefits, for example, 15% of people in the United States drink from private wells, where they are supposed to monitor their own nitrate and they're told what the requirements are. The evidence we have is that pretty clearly people don't do that and may in fact be drinking water with higher than 10 parts per million concentrations, but we really don't know that. And even if their well is above the 10 parts per million, they might be drinking water from a bottle. Okay, there's a ton we don't know about that, but that is a number and a value that should be included. in addition to costs of cleaning water, costs of expanding, and so on. Those are part of what should belong in these numbers. Exposure to polluted water through drinking it. You go to the beach, you drink something, you get a little diarrhea, you get a little skin rash, and you say, you drink too much Coke, and we don't really know what all of those are. But that, conceptually, that should be included, and often is not in many of these studies. We've done a lot of work in recreation and the evaluation of if we improve water quality, fishing, swimming, boating, lots of work in that area has been done. We've done a pretty good job there. Productivity effects and commercial fishing, recreational fishing, we've probably done some good work there. There's probably a few missing pieces, but I don't know that I can really assess that. Local amenities. People love to live near houses. We have lots of evidence in the hedonic literature that shows where that shows up. I don't think we really understand how much is being captured in those numbers and what's not being captured in those numbers. Some of the work that Joe Shapiro and Dave did, I think, really brings to the fore of what is that, those numbers that show up in housing values really measuring. Is it all-inclusive? Is it a subset? What is it? I think we need to think more about that. There's lots of evidence that there's infrastructure damage. Not clear whether we really fully capture all of those values. And then the area that I've put on here is non-use, but it's the whole suite of ecosystem services that we get from water and water quality, related to habitat, related to birds and bugs and all kinds of pollinators and all sorts of things that could be really small or not, that we really, I don't think, know much about. And I'm not the only one that is convinced that we don't know too much about this. The EPA also isn't sure that we know very much, and put out an RFP requesting proposals for people to study more stated preference work, non-market values of that set of ecosystem services and non-use. As part of that, I have a short pitch for you that I think as economists, as ecologists, as people that have interest in water, we need to work a lot harder on generating numbers and estimates to populate social costs of water pollution. I bet everybody in this room has heard the term social cost of carbon a lot. This term, the numbers that they use are fraught with problems, but they are a very effective and useful tool for arguing, are they too high, are they too low, what do they include, what do they not include, so on and so forth. I think that we should have the kinds of discussions we have about social cost of carbon also with respect to social cost of water pollution. And so that's kind of a side advertisement. And in my work at Cornell and in the Atkinson Center, they're funded me to do some more community building along that line. So if you're interested in that kind of concept and idea, let me know. Okay, but back to the point that we don't know enough. There are, I have a couple quotes for you, and then then I'll go right in for another 5 minutes into what we're doing and pick your brains for ideas. Alma Garland, who is the chief economist at EPA, what's his title? Something like that, has written a number of really useful pieces and published them in places like Science Policy, one with Ricky Revesz. He specifically notes that when EPA does benefit cost analysis, if they've got something they can't carefully quantify, if they're not sure, if it's uncertain, they zero it out. Okay, that's not actually good benefit cost analysis. We ought to weight it by the probability that it belongs in there or something. But the point is, that says that benefits are not unbiased. If every time you have something you're not sure about, you put it at 0, there's a bias, and that's called the downward bias, okay? But it's also a call to science and economists that they can't measure these things, so we need to do a better job of doing it. And maybe they're dinky. Maybe they aren't going to make any difference. But we don't know that until we measure them. EPA put out a solicitation to, about 4 years ago, to ask people to start to fill in some of these values with a specific focus on non-use values for small rivers and streams, which is kind of the hardest thing to think about, and is arguably an empirical question whether there even is non-use values for small rivers and streams of all sorts. I and a group put in a proposal. That's our team. EPA funded 5 of these, so we are just one group that got funded, and they're sort of scattered around the country. We have been working for several years, and I'm going to show you now where we have, and you're going to help me make it better. We want to, let me just go right here. The focus of this work is to get some information for EPA about water quality values that are outside just the standard usage. For 35 or 40 years, people have been doing valuation studies of water quality, both revealed preference, stated preference, using a water quality ladder focused on use. So if you have very pristine water, you can drink it. If you have really gross water, you shouldn't even touch it. Okay? It's okay for boating, fishing, swimming, and drinking. All use-related concepts. So what we are doing, and a few others have done before, Abatement did some cool work a few years ago that we're building on, is think about going beyond use metrics when we discuss and talk about this work with people to non-use. And I'll skip this and go right to our first picture. What we're drawing from are biological indicators in addition to use indicators. Biological condition gradient is the thing I had on that last picture, that last diagram, which is used by ecologists. Probably people in this room know more about it than I do. So who knows about BCGs and works with them or has heard of them, or anybody? Yeah. Okay, I got a few. So if you really want to know what these are, ask somebody. But the idea is, as explained by an economist, that our ecologists have helped us work with, is that there are certain indicator species that help us understand how impacted an environment is. Turns out insects are really good indicators, the breadth and diversity of insect populations. So if you have a very natural system that has been impacted by people, altered by people very little, then you're going to have a set of bugs, what regular people call it, insects of a certain, a set of those kinds of bugs that insects, and those are the food groups. They're all, it's not the insects themselves that are important. It's the fact that they are measuring the impact on the ecosystem. As you have more impact from humans, more changing of the landscape, more pollution, you get fewer and fewer of these insects, and the numbers that do well and the robustness changes. So they use these indicators. And this is, for example, There's 6 different levels of these biological condition gradients that take us from a very natural state. This is a cartoon we've worked on with our ecologists that indicate a small river and stream, a sort of typical stream in the Midwest in our ecosystem with specific typical flora and fauna, stream bed, and the type of biological diversity in insects that would be found not necessarily in this stream, but in the ecoregion that this stream would be in. We added fish because people aren't all that lovey-dovey about bugs, okay? And we are developing this for people, for a stated preference survey. So we're doing this back and forth to try to be ecologically, scientifically, accurately reasonable, but also things that we can communicate with people about the health of this system. So this is our current depiction of completely natural, unaltered state. This is a level 3. Okay, you can see we now have more gunk. It's a little bit more polluted. That's altered the stream coloration, what can live there. The biological diversity has changed a little bit. We've gone from a 1 to a 3, and now here's a 5, okay, which is worse. And we're trying the signage as a way to communicate uses to people. We're going to do some focus grouping more officially formally with some of this stuff, but this is kind of where we are in our informal. And here on one picture is the full suite of the 6, all the way from the natural state through to, if you've ever driven across Iowa on a cornfield and you see a ditch, there you go. That's our ditch. Okay, massively altered, tons of nutrients, also altered landscape, and so on. Okay, I'm going to stop now. I went 5 minutes later than I should have in my talking, but that should leave us 10 minutes. Please comment, tell me comments later. I'm looking for feedback. We are at the very early stages of developing this survey instrument, which we're going to put in front of a bunch of people and ask them to make trade-off choices faced with dollar differences between different levels 2 and 4 and try to elicit how much they'd be willing to pay. So, comments about this or anything else? Yes, please.
So you brought up history at the beginning of your talk, which was fun. I'm going to throw some fun back at you a little bit. If you were to come to North America as little as 200 years ago, the Western landscape would have been full of millions upon millions of bison, literally shitting everywhere, and nitrate pollution and phosphate pollution into most of the water bodies. And you would have rivers and things looking like the far end. So you have that also happening in the Serengeti in this day and age. So is it a good thing that we annihilated the bison?
So your premise is completely at odds with my understanding of what the landscape looked like 250 years ago. So I guess I'd have to have a little more understanding of that.
So I mean,
it was tall grass prairie as well. I thought that's where you were going to go. And
right,
short grass prairie.
But we're basing water quality standards on something that isn't compatible with historical ecosystem functioning. That's the issue I have, is if you really want to take into account ecosystem services and environmental services, it's really important to understand first how we've transformed the entire landscape, and now what we define as high water quality is inconsistent with what was historically a healthy ecosystem by the way we define healthy ecosystems. And in Serengeti, you have the same thing. If we want to improve water quality, we've got to actually annihilate the wildebeest. And if we annihilate the wildebeest, then there's a huge social cost of carbon storage in that system. So, you know, I'm just wondering how we adequately, I don't see an adequate implementation of ecological principles into this valuation. You're just looking at water not as a part of a watershed, and really thinking about sort of how we come up with more ecologically appropriate definitions of water quality. That's really what my concern is.
Well, I will certainly share that with the ecologists that we're on our team, but it is, as I said, quite at odds with what they have told me and what I understand was true. We had very deep soils. I don't think that there was very much loss of nutrients from those herds into waterways. It went into perennial grasses with 8-foot. Anyway, it's an interesting thought. I totally didn't expect that, and I will definitely share it with Christy and Jacques Finley, our ecology team. Yes.
Thinking just about the stated preference and, oh, great. Hello, okay. I guess I would be concerned that there would be a lot of potential for understating how much people value this ecosystem service based on these pictures, and that would be primarily, like you said, people don't care about insects, or maybe people don't live near streams, and you listed all of the benefits that can come from water quality protection aside from just this stream, and it goes down to the availability of agriculture and maybe just, I think it could be very useful to take some of the benefits that don't seem directly connected to water quality problems and show those pictures and see how much people would be willing to pay for things that would be enabled through water quality protection but are not necessarily obvious. And maybe people don't even know that they're answering a survey about water quality protection, but then you have a better sense of how much they value all of those other things. And then the other question, and I'm not sure this plays into the study, but I'm wondering if you looked at co-benefits like, for instance, a lot of measures to protect stream flow also will lead to more constant flows and reduce flood. And are those values quantified in your studies?
Yeah, it's really hard you always have to ask the question, what are we trying to value? And what's the baseline, and so on. Exactly right. And so we want to measure water quality, but one step back. We want to have numbers that come from our work that EPA can use to help improve those benefit assessments, whether it makes them bigger or small or whatever, but to feel like they have better estimates of the value of water quality improvements that would be impacted by their regulatory measures. That's hard and a general thing to do because it depends on what you do, what the co-benefits are going to be, and whether this can capture that. So your question is spot on. It's hard, and we continue to grapple with that. And I think I can't say anything. I could blather about it more, but I don't have any firm answers except to be really clear about what we think we are capturing and what we think we're not. But it's a huge point, really
so right
good.
Now would you say it's sort of like the things that are zeroed out, the things we're uncertain about are kind of zeroed out in the calculations?
Yeah, but we also don't want to end up double counting things. I mean, it's, you know, we want to get it right, and for any particular study, what's going to happen, the pieces, I mean, to do a good benefit cost study, the first thing you have to do is figure out all the different things that are going to be impacted by whatever it is, your regulation, your whatever change you're making. How does that affect what set of ecosystem services? Who gets those benefits? Who bears the cost? All of those, and we want whatever numbers we come from here to clearly map to some of those pieces so that EPA can say, okay, this is captured, but this isn't. And then they can avoid double counting as well as undercounting. There's a question over here. We still good on time? We got another couple minutes?
Hi, thank you very much for your talk. I'm interested to understand what's the target population you're going to survey. So is it going to be anyone really, or it's more targeted to scientists and experts? And would you, I don't know, would you expect their answer to differ, and if so, in which direction? And it's also like, does it, do you kind of survey people that are close to this type of environment, that are more familiar with those type of environments, or anyone in the
We're
area?
definitely want a random population survey. So we will not give them all 6 of these. We're very much at the design level right now, so we're showing people that are science-y and know something about, to try to be sure that as close we can that we're being reasonably accurate. But we want to know, because we want to be able to inform benefit cost analysis for national analyses. Ideally, we will have a representative of the U.S. population. That's the target. And we got a long ways to go to be sure that what we can give people pieces that they can actually understand and do something sensible with. Eli?
Thanks, Cathy. This is great. So I guess one of my questions when we do these, we often think about the with and without the policy change that we're thinking about.
Yep.
And
We're going to give them a baseline of where we're starting from.
yeah, so I guess that's my question is, can you talk a little bit more about the baseline? Because it seems like it's often implicitly at 0 in the analyses.
No. Excellent point. And yes. So for most of, so this is for the Midwest, Iowa, Illinois, because of corn country. We are also putting together a map by 8-digit watershed, Huck-8s for those who speak that lingo, of what the average BCG is at the starting point, as well as the distribution across the entire Midwest, so people can see what they have as well as elsewhere. Part of the reason we also want to do that is we want them to be able to say, a lot of them are here. Okay, so where I grew up, like here. And so we also want people to be able to say, oh yeah, that's here in Bettendorf, Iowa, it looks like that. And oh yeah, that's Skunk Creek, I can see that creek that's kind of like that. So we want them to mentally get that baseline, and then we will be proposing deviations from that. So it's what they know and what the current condition is. We're not going to start with pooping bison that do something. We're going to start in this region and then talk about, one increment or 2 increments. And those of you who know Dave Kaiser know that you put him up to this. He wants the number of what the value of one marginal unit of N nitrogen change is, so he can publish another AER paper like these guys do. Okay. But anyway, I want to know the values of broader things and more things, so we can do natural capital valuation for the whole changes and whatever. So yeah, the baseline is huge, and we're still working on how to communicate that baseline.
We are out of time.
Yeah.
Thank you very much.
Yeah. Thank you, everybody.